Hey folks, sorry I was a little late. The Ceph users meeting is ongoing. Hopefully that will wrap up soon. And I don't know if we have, it looks like we do have folks from Core already, so that is excellent. All right, let's see here. So, to get this started, we don't have a whole lot in pull requests this week. There were two new ones that I saw. One starting out now is just a documentation PR from Josh Solomon, maybe eventually working on a primary balancer mode, which is coincidentally maybe relevant for the talk that we're going to have today. And then also another PR for the MDS from Patrick to skip inode with cap iteration for empty directories. I confess I did not look at that closely, but it was approved, so I guess it looks good. Let's see. Patrick, are you here? No, not this week. All right, so then moving on. Just one closed PR this week. Casey, it looks like we did merge this optimization for request timeout PR.
Woohoo!
Yay! Excellent. Anything of note? Everything looked good from everything I saw in it.
Yeah, not really. Just a big thank you to Mark Kogan for all his work on that one.
Yeah, he's been excellent. I just saw he sent an email about a regression master we need to track down, so he's on fire right now. All right. Well, very good. Other than that, I did not see any specifically updated PRs this week, and we've still got a whole ton of stuff in the no movement category. Looks like it's just been a little slow over the last week, but still lots and lots of stuff here to review. And I know I've got PRs out there that need updating that I haven't gotten to. So anyway, that's about it as far as I saw. Was there anything I missed, guys? All right. Well then, if there is nothing else, then let's move on. So today's topic is about this standalone Ceph balancer work that Jonas has been working on. Jonas, are you here?
Oh, I am.
Oh, very
I'm
good,
here.
very good. Excellent. Well then, would you like to talk about your work?
No.
Sorry, what was it, Laura?
But oh no, connection seems to be lost for Jonas.
Yeah, that's what I was wondering too. At first, I just wanted to make sure it wasn't me, but here we go. Hello.
Yes, I'm back. I don't know, Blue Jeans and my Firefox don't play well together. It just out of memories, apparently.
Oh, jeez. All right, well, you're loud and clear now, so go ahead.
Yeah, that's cool. So basically what I've been working on is this balancer thingy, which uses the regular Ceph API stuff from with an external Python script. I'm not sure who of you has looked at the code, maybe. Probably not so many. Some of you answered at least and tried it. So I did a mini presentation to give you an overview of what it does, but I hadn't had much time. Let me just fire it up. 1 second. You entertain the crowd until I manage the. Oh, your video is frozen?
Oh, no, I just turned it off. I can entertain the call. Let's see, what should we talk about? Well, maybe in the meantime, I was looking, Casey, at this message from Mark Hogan about this regression in master. Have you looked at it at all?
I saw the email, but haven't looked into detail, no.
Okay, okay. At first, I was looking at the wrong PR. I was looking at this first one he mentioned, but here, let me post it in the chat window. Um, it appears that the one that Mark found, I think it's this one here, and I was trying to understand why. I mean, this is just a doc, so that can't be right, unless I'm reading this wrong. Oh, he didn't do the. Sorry, I apologize. He didn't do a bisect on this. The PR he noticed the problem in. So something between this one and the other one. So between 42046 and 43969. All right, so I guess there's not a lot to discuss on this one right now. We need to first figure out which PR in here actually caused the issue. But at least it's a starting point, so that's good. All right, Jonas, I see your screen.
Yay. Okay,
are
so the
you-
presentation is really brief because I had no idea about the format, that it should have been an actual talk or something.
Oh yeah, don't worry. We're not picky. So give whatever you got, and we can discuss.
Yeah. So the idea of my balancer is quite simple. So what we all know is that, of course, the fullest device determines the cluster fullness. So whenever you manage to empty the fullest one, the whole cluster gets emptier. And that's basically the whole algorithm. I try to empty the fullest OSD, which changes, of course, in the process, and move it onto other drives. But the selection process is, of course, difficult, and you have to respect all the constraints with crash and so on. So I had a deep look at the original balancer, the MGR balancer, and it works quite nicely for both of my clusters. So I have two. One is rather an abomination with half a petabyte on basically a single node. Don't ask. And the second one is the cluster here in the university, which I'm working on. I'm a PhD student at Technical University Munich, and I'm doing some research on light field microscopy, but on the other hand, I'm doing infrastructure work and maintain in the data center of the math and informatics building. I maintain, among others, our storage cluster. And this is the storage cluster that gave me the headaches and led to the implementation of this balancer. Because the model, what's happening there is we ask shares to buy servers or even donate servers they already have and using for their file servers. And we want to create one big cluster, basically. So this thing is very heterogeneous, and there's many differently capable and sized servers, and they are coming in over time as we persuade more chairs to contribute or to take part. And there it happened that the crush in combination with the balancer was no longer able to do any good distribution of the data. But by just looking at it, it was obvious how it could be distributed, but it just wasn't, because the balancer, just didn't do anything anymore. What happened there is that there were nodes so big that Crush could no longer fulfill the placement constraint directly. So, like if you have one huge class, one huge node, and 3 small nodes, and you want to do whatever 3 replica stuff, then you cannot fill up the huge node more than you can place the other 3 copies on 2 of the remaining nodes. That's clear. But now what happens next is that the manager balancer, it detects, oh no, this node is now not as full as it could be, and I'm trying to fill the missing space by moving between buckets, so from host to host. But that can't be done since the constraints are not fulfilled anymore. But it is possible to move things around when you don't move stuff from bucket level to bucket level, but instead just have a look at the OSDs, try a move, and validate the whole crush constraint. And this is what I did implement then.
Just
The
a
script
question.
now has over 1,000 lines nowadays because it checks a lot of things. I basically re-implemented the crush check and yeah.
Jonas,
Yes?
just to clarify what you did, it's interesting. So instead of doing the balancing in the bucket level on the node level, you moved between OSDs. You did balancing of OSDs within the same node. You moved from, when you could do it, from different OSDs on the same node to keep them, the OSDs in the node balanced when you couldn't do it in the outside world. So I'm asking a question whether I understood you correctly.
Basically, yes. So maybe it's clearer if I just show you the algorithm here, because then you see what I'm moving. Let's just assume we didn't find enough moves, and we just start here. So I'm starting to sort all the OSDs within one crush root. So the fullest one is the top one. So this from OSD now is the fullest OSD in the cluster. And what I'm now trying is moving off PGs of this OSD to anywhere else, of course, with the condition that the new target is not fuller than the one we moved from. So on that OSD I want to empty, I try to get candidate placement groups. So I just look, what's on you? This would be a good candidate to move off. And then I try to place it on the emptiest OSD. Because ideally, when we move from the fullest to the emptiest, then everyone's happy since the balance is getting better. Of course, this can only be done when Crush allows me to do this. So when this constraint is fulfilled. And it also only makes sense if actually the variance of the cluster got better after this move. So that's another check I do. So I totally ignore the cluster structure here. I'm not looking at any buckets or hosts or any grouping of OSDs. I do validate for that, but my only goal is to empty the fullest OSD to somewhere. And this works surprisingly well. And was able, I mean, in our cluster, I gained like, let's say, 200 terabytes at least. And over the course of the runs I got, it's probably like half a petabyte or even more, where the original balancer just didn't do anything anymore. Because of the aforementioned, it doesn't know it can balance in other hosts because one of the hosts is too empty. Josh, does it, I mean, what I expected from this talk is, of course, very much interactivity, so please just ask.
So I just have a question. Do you also take care of the pools you do it that you balance? Each pool is balanced by itself, or you do it globally?
I do it a combination. So another constraint check I do for do I want to move this PG is I create a PG count per terabyte basically, and I only want to move it if the PG count from the source is higher than average and the PG count of the destination is lower than average per pool. So that means implicitly I balance the PGs of one pool over all devices.
So eventually, for each pool, you have if you take a pool and OSD and you could do the pre-calculation based on the weight and say this OSD needs X point Y PGs, and you would make for each pool it's either X or X plus 1 for each pool separately. Okay.
That's true. So within each pool, we maximally get we either have X or X plus 1. But since we are looking at the OSD sizes globally, it cannot happen that because of the multiple pools, the one USD is plus 1 plus 1 plus 1 plus 1.
Yeah.
Because these we move as we have also the global view, and since it's just too full, and then I move it somewhere off, and then it becomes a plus 0 basically.
Yes, I understood this. You fixed this problem. I didn't understand exactly the other problem. Now I understand it.
That's great.
Okay, it seems like really good work.
So currently, the PG candidate calculation is totally simple. Totally simple, stupid. I just sort again the shards on the source OSD. Then I do some more calculations if this candidate is a good one because of the size, the fullness difference of a source and target OSD. But I'm sure we can do even better. So some ideas we had also on the mailing list is that we sort this PG candidate list several times by several properties. Of course, by the size from big to small, because it's if it's possible to balance a huge chunk, then we should do that. And the small chunks are eventually also balanced later in later iterations, since we just keep this moving on and on until we're happy, or the variance no longer decreases. Then I would like to prefer PGs that are remapped. So because they are currently in the process of moving, and if we generate a candidate, it would be even better if we move it to another place, then it makes sense to abort the move and just select a new target. Then currently this thing does not clean up anything at all. It just adds more upmap items, or if there's a move in the opposite direction, it does move it, but it's not preferring cleaning up. And since the goal should, of course, be to be as near to the crash state as possible, we should also prefer removing the overrides, the upmaps. And in the same way, we should prefer PGs that don't have any upmap yet, or have the least number of upmaps, so the distance to crash also remains minimal. And why is that good? Because when we add new hosts and so on, then all the things are just cleared and remapped and reordered. And then more imbalance occurs as soon as crush updates. So the nearer we are at crush, the better, hopefully. Yeah, so that's the overall idea. I mean, what I also thought of is to operate Ceph in a crushless mode. Because what you could also do is, of course, create the perfect placements just by solving the whole optimization problem in an actual optimization solver or as SAT solver. So you could formulate this as a quite complex problem, stuff it into Z3, and it spits out the perfect placement. And of course, you could also, by the same way, generate a perfect migration when you change the crush hierarchy and add something new or remove it. But that, of course, is quite against a core design feature of Ceph to have this crush thingy. But I think it should be something one thinks about, that it can be possible to run Ceph without any crush, just with a mapping fed in. Because I think the crush is not ideal in all conditions. I mean, we are constantly fixing it with some add-ons like this balancer. And other storage systems don't have this cool crush feature, which is on the one hand bad, of course, because crush is so dynamic and awesome. But on the other hand, manually specifying where you want to have what is maybe not that a bad choice for some clusters. I mean, we have thousands of upmap items now to have our cluster balanced. And yeah.
How many
What else can I
OSBs do
say?
you have?
Sorry, Josh?
How many OSBs do you have?
Well, that's a very good question. I have to look up. So the cluster currently has a raw capacity of nearly 3 petabyte, and it does have 600 USDs.
Okay.
So rather medium size, I guess. But it has a special feature, like I mentioned earlier, that is really not uniformly bought, but rather shares giving us a server for whatever. I mean, we do have a fiber channel storage also for the virtual machines and so on. And I also reused our old fiber channel storage for Ceph. So I attached all that these enclosures with single drives to Linux servers and made the fiber channel software defined. So there's lots of specialties in this cluster. So my idea was that maybe it is or should be possible somehow, apart from the API that we, of course, all love and use, to have different balancing strategies in Ceph itself. So currently the manager balancer is very awesome, but like I said, some corner cases it can't optimize, and maybe we find some way to integrate that, because I think other clusters may also profit from that.
Yeah, I think I agree with you. So I joined a little late because I was in another meeting, but I think the idea that I got and the motivation behind you writing this wrapper or or your own balancer was that when you have unequally sized devices, it is known that the upmap balancer does not do a good job, and I think that was kind of your motivation, like you said, that your device
Yeah,
sizes.
exactly.
So you had
I don't know,
things.
when did you join?
I joined maybe 10, 12 minutes after there was a user dev meeting going on.
No worries, no worries.
Yeah.
I'm just trying to interpolate how much you know then about
I
what
think
I
you were
talk.
just you were talking about you were in the algorithm, so I think I got the interesting
Okay.
bit.
Yeah,
Yep.
that's good.
So
Yeah.
and going back to your I mean, it's awesome that you went ahead and did that, right? Because in general, the balancer, the upmap mode was written with like equal or like somewhat equal device sizes in mind, which can be a problem in a scenario like what you have, right?
Yeah.
And going back to your point about like the balancer should have different modes where it should be doing stuff based on the need of the cluster versus one umbrella strategy that it's using every time. I think we also felt the need to do that, and Josh is particularly also Josh, and I think we have another a person who will be working on these aspects. The idea of like currently either mode of the balancer is just using just the number of PGs, right, to balance. The idea, like you just mentioned, about the actual utilization of the OSDs is not taken into consideration. So
Yeah.
that is something, that is the other, it could be a separate mode. It could be another layer that we add on top of the existing balancing that the upmap balancer does to also account for the actual utilization, not just the number of PGs. Because again, it's the same problem. If the PGs are not equally sized, then it actually doesn't balance that well. The other aspect is about the read bandwidth or the read throughput that you can get out of a well balanced cluster. So currently what happens is we don't account for how many OSDs are becoming primary for how many PGs after the balancing completes. So the primary balancing part is missing, which can affect the overall performance of the cluster when you're trying to read, or like one OSD is the primary for too many PGs, so you're trying to do a lot of reads from that particular OSD. So that is I think that is one first step that we have decided that we will work towards. Essentially, the upmap balancer comes up with these balancing strategies. We have another layer that we add on top of it, which will actually look at how equally or unequally the primaries are balanced across the cluster. And if it thinks that there'll be obviously a threshold. If we think that it is beyond the threshold, then we just do something like what you suggested, like swap the mappings, do some upmap item stuff, and the final balancing that will be applied will also take into account this primary stuff. So that is definitely Go ahead, John.
I think you missed something at the beginning, something very cool that Jonas did.
Go for it. Yes. Yeah.
He got into a situation where he has one, not different size OSDs, different size servers. And he had one very big server, which was obviously a crash bucket. And it was not full enough because it can't be full enough because it was too big relative to the size of the cluster. But then the balancer stopped doing balancing because it couldn't do, but it still could do the balancing within this server by moving within OSDs to balance the OSDs within this server, because eventually we don't want to balance servers, we want to balance OSDs. The first OSD which is full is so this is something which is currently not handled at all by the existing balancer, and actually
that's also
this one. This is
the main motivation thing. Thanks, Josh, that you understood this.
Okay, that is the interesting bit I've missed. Okay, thanks, Josh, for filling in.
So that's an addition. So actually, found two bugs that we had in the existing balancer. This is one, and the other one is since we work pool by pool, it could be that the plus one OSDs, you get the same OSD gets plus one many times, it becomes bigger than others. And so two existing bugs, we could say, in the existing balancer that actually were solved.
Yeah.
So this form of the balancer does not balance per pool, right? You could balance across pools as well.
It only balances per pool, but it does not. So earlier, I know there was a change some time ago. Earlier, the balancer balanced just globally. Then it was changed to only balance per pool.
Yes.
now it no longer has the global view, and it doesn't know that one OSD has more PGs for the overall PG average per size than it should.
Yeah, I think that I remember what change you're talking about. There were clear performance implications with the strategy that we were using at a global levels, and there was a lot of proof on different kinds of OSD maps and different size clusters that doing it per pool was much more efficient than doing it on a global level. But that is, yeah. Having said that, that does not mean that we shouldn't revisit what the bottlenecks were and try to.
Yeah, there's downsides to both, right? If you optimize
Yeah.
for a particular pool, then if your workload is spread across many pools, you might not see optimal behavior. But if you have one pool that's the primary usage for the cluster with lots of pools that are rarely accessed, then you may be better off optimizing for that specific pool.
Mm-hmm.
Yeah. And what my balancer basically does is both, because the approach is so stupid. It just validates constraints, and the constraint of am I in the limits for the global view, and am I in the limit for the pool view is both accounted.
It seems to me like you would want to look at either how big the pool is relative to the other pools, or possibly looking at recent usage and saying this particular pool is seeing the most usage and we want to weight the optimization towards it relative to other pools, maybe.
But I don't get why this is important, since it is possible to balance each pool perfectly and respect the overall balance. You don't have to prefer a pool and do a trade-off to not consider other pools and only want to balance.
In the extreme case, what if you had one pool that was skewed extremely heavily towards half the cluster and a different pool that was skewed very aggressively towards the other half of the cluster? In that case, you have two optimal scenarios depending on if one pool was heavily used or another pool was heavily used. And the average would be that you just spread work across the entire cluster, right?
What do you mean by skewed? When did that happen?
This would be a hypothetical case, right, where you have one that's one skewed one way and one skewed the other way. In practice, you'd never have that, but you might in practice have a scenario where one pool is somewhat weighted towards one set of OSDs, and another pool is somewhat weighted towards another set of OSDs, just by the way that the PG distribution happened to land, right?
No, but Mark, he said that he specifically for each pool, each OSD gets either X or X plus 1 PGs. So each pool is balanced perfectly, assuming we have a power of 2 PGs, and all the PGs are the same size. But I asked Jonas, so that's why I jumped. But he said each pool he optimizes concurrently each pool separately and also globally. So it's not, it couldn't happen what you described after balancing. It can happen before balancing.
Jonas, do you have an example output of before and after? I want to make sure I understand correctly because I don't understand maybe how that piece works.
How could I do that?
You don't have to do it now. Just it might be maybe someday if you happen to have it
I can
available.
just draw on my screen and try something. Maybe it helps. Let's see if the technology works. Okay, sharing.
Yeah, we see your screen.
So you now probably also see my beautiful drawing. Okay, maybe I should turn off the web camera, otherwise it looks really weird. So let's assume you have these OSDs like this, and currently this one is very full. This one's not full at all. This one is, and these are like 50%. That's good. So our ideal goal would of course be to have this one also at 50% and this one also. Now this can be made up because of several placement groups being several pools being not well balanced. So Mark, your question was just that I'm going in the right direction. Do you know the +1 problem?
Why don't you describe it?
Okay, so this OSD. Okay, let's just assume this. We have only one pool, and this one here is the +1. This one is a -1, and this is all 0, meaning they all have the perfect amount of placement groups relative to the available storage amount, no matter how big these OSDs now are. Because this the left placement group should actually be here. So this is only a per pool view, you know?
Mm-hmm. Yes, agreed.
So now if we do the same thing with 2 pools, it may be that we end up with something like this. So we have again these pool OSDs, and now this one is very full, equally balanced, because from the ideal count, the first pool has a +1 here, and the second also has a +1 here. And the others are at 0. Because the first pool, the perfect balance of the first pool, because the number of OSDs is not dividable by the power of 2 usually. The first pool perfect balance ended up being all the OSDs having the perfect amount, except this one because we needed it to reach our to take care of all the PGs. Okay, maybe I need more additional stuff. Let's assume our size is 5. Also, of the pool, right? So you have 1 PG here, 1 here, 1 here, and 2 here for pool 1. Are you with me? So we
Sure.
distribute the 5 PGs like that. Now we have a second pool, which we distribute the same way, which is I'll write it in another color, which is
Can I make
also
this
1, 1, 1, 2.
Sure.
And now if we had the global view, we would know that this +1 should not be here, but instead be here, for example, or any of the other OSDs.
Yeah. So my question for you would be, what if you had a distribution where you had with, like, let's use your size 5 example, and in pool 1 you had let's say a skew of an additional 2 on the first OSD, and you had a skew of 2 on the last OSD. for the second
Mhm.
pool.
So you
So
mean
you,
I'll write it down like yeah.
So Mark, you suggested that you have 2, 1, 0, 2. That's what you suggest. So one OSD would not get anything, one would get 1, and 2 would get 2. That's what you suggested.
so yeah, it's skewed differently, right? In one
Okay,
pool you have a skew this way, and then in the other pool you have a skew the other way.
I get.
So
Okay.
yeah, and it might be like 2, 1, 1, 1 for pool one, and it might be 1, 1, 1, 2 for the second pool.
That's good. That's very good.
Yeah, that's a good example. What was can you say again the second 2, 1?
So like 2, 1, 1, 1 for the first one, and then
Yeah.
1, 1, 1, 2 for the second pool.
Okay.
That's Mark a perfect. That's good. What is not good is eventually 4, 2, 2, 2, because currently you have 3, 2, 2. You still kept the skew here. The first
We don't have any
one
plus
couldn't
ones
happen.
here now. Shall we do it with 3 OSDs? That's.
No,
I mean, these
Well,
examples are.
but the point, right, is that if you're say that pool one is the only pool that you actually use, and
Mhm.
pool two is actually just is unused, is not important,
Yeah.
then you would want to do differently, I think, than if those two pools were used equivalently.
And how? I mean, it doesn't hurt to also balance out the unused one.
So maybe I'm misunderstanding how the code works, or maybe you really can do this independently. I guess the problem that I remember hitting in the past was that you ended up having to optimize for one or the other, and not you couldn't get perfect balancing with both. And that's, I think, the hang up that I have. That's where I'm not
Okay.
understanding what you do.
Okay. Um. Okay. How can I
No,
phrase my
Jonas,
understanding?
Jonas said that he can do both. That was good. He actually is doing both. So I think Mark, we could, if he proves it, then your assumption that you can't do both is just wrong assumption.
Yeah, and that's what I wanted. I want to be proved wrong, because I looked at this a while back, and I guess what I don't understand is how you do perfect balancing of all pools, even in the situation where one pool is the only one used.
Okay, let me think quickly. I need a good example. Should I try writing more examples or trying to explain again why I think it optimizes for both? What do you think helps you better?
So okay, let's look at the first pool one, where you have just like 2, 1, 1, 1.
Let's
And
take 6 OSDs, shall we?
okay,
6 with 8 PGs.
okay,
Then we have more PGs than OSDs. And we have 2 pools with 8 PGs, okay?
perfect.
Great. So then let's say currently, I mean, I can just create a wrong distribution and then basically walk through the algorithm. And then I think it should resolve itself. I hope.
In addition, can you talk just in your example? Can you say how much data is placed in each of those pools?
We can place the same amount if you like.
Let's say it's very heavily skewed towards the first pool.
Okay. So then we do the blue pool, which is like 80% usage and 20% of the other. Is that good?
Yeah, sure. That sounds perfect.
And then we'll take the red pool.
%20%, right?
Oh, yeah, sure. Yeah. Okay. So then we'll draw these 6 funny OSDs. By the way, what time is it for you?
We've got like 10 minutes left for the meeting, so Brady has to wrap up pretty quick.
Okay. So let's we have I'll just write the number of PGs for each pool for red and blue there. So we have 2. I mean, we're not even looking at host bucket stuff yet, right? It's just within one host currently. So it's just
Sure.
OSD middle.
Yeah. Like this. Okay.
And
No, it's you need 8 PGs.
oh no, I have
50
6.
PGs.
Oh yeah, you're right. Oh damn. So is this 10 minutes a hard deadline? Do you have other
No, oh,
opponents?
no. We go over regularly, so we might lose people, but that's okay.
Yeah, that's very soft limit, and it's often overused. With pleasure when discussion is good.
Yeah, that's cool. And you're all at home now, or somewhere at your office?
Every person is in different location mostly, so.
Okay, so all from wherever. Interesting. Okay. I'm currently sitting in the university in Munich. So now let's create something that is really full, like this.
We just for my own benefit, can we skew one of these pools very differently than the other one?
Okay.
Let's just say that pool 1, maybe we end up with like 3 on OSD, the second OSD in your picture.
So pool 1, you mean that's the blue one?
Oh, the red one.
The
Sorry,
blue
the red
one.
one. Sorry. It doesn't matter, I guess. But I was thinking the red one. Sorry.
And you
So like
want on
OSD 1. Let's put 3 there
let me
instead.
just number those also.
Now, put 3 instead of 2 and move one of the ones to 0. So we have you have really
Okay.
imbalance. One was 0.
So then I'll just create this one to 2 and this one to 0. Right?
No,
So only one gets
one
2
would
red.
be 0, 1, 3. Make even 3 on 4 or 5.
Okay. Why not?
The goal would be to make it so that these pools have very different distributions relative to each other, right? That one of the OSDs in pool 1 has lots of PGs, and in pool 2 it has none, or very few.
So make in OSD2 make 3 reds.
Okay.
It would be 3, 6, 8, and in OSD4 make 0 reds. And that's okay.
Yeah, exactly, something like that.
In OSD5. Okay.
0.
4, 5. You still need 2 reds to put it on 5.
Good.
Yeah,
Okay.
exactly, something like this.
3 actually.
Yeah.
I didn't check it now. So
Yes.
we have 4, 5, 6, 7, 8. Yeah, we need another one. Do you want it on 5 or somewhere else?
No, make it on 5. It's good that it's totally, we have imbalance in all dimensions. Yeah.
Yeah, and really with this few PGs, this is not unlikely, right? Like this could happen.
But the hashing is perfect. Mm. Okay, so now let's sum up the current sizes. So we have 180 here, whatever percent means now. 80 here, 60 here, 100 here. Und hier haben wir
220.
good. So now let's run through the algorithm and hopefully see that the right thing happens. So we agree that the ideal distribution for each of the PGs would be 1 PG per OSD per pool, right? So one possible ideal distribution for red would be this. And I like this,
Sure.
right? And now this one here is the +1 because it's one more than the ideal amount. And this is also an ideal distribution for the blue pool because the blue pool also has 8 PGs. And one possible ideal selection would be the exact same placement. So when you come up with balancing each pool individually, you could you end up basically with, for example, this pink placement. Agreed?
Yep, agreed.
Good.
Oh,
Well, I
right.
can temporarily agree, but I do not like that the new distribution does not have anything to do with the one we started from.
I mean, that was just theory. I mean, that was it's clear what the +1 is in this case for Mark.
Yeah, right. I mean, you have to, right? Because
Yeah.
there's no,
That's the
you
point.
pick something.
Exactly.
Yeah.
That's exactly the point. So now I delete this. But now that we know what the +1 is, let's start moving stuff around. So the fullest OSD is obviously 5. So we start emptying 5. And now by some magic pick, we have to select if we either move blue or red off 5. And the stupid approach currently in use is sort them by size. That's what I was listing in the slide. So basically, we have to decrease the 2 and move it somewhere else. And the ideal candidate is, of course, the emptiest device, OSD2, where we place it over. So I can create a new line here if you like each balance step a new distribution. And so we're looking at 5, sort the PGs by size, take a blue one, Now select the destination OSD, sort it by size, which is in this case OSD 2. Now let's check, would a move of blue from 5 to 2 be okay? Then let's check crush and also check, and this is now the global and local optimization part, and also check, does 2 have less than 1 PGs of blue? So this is another check. Has to be smaller than 1. Because in the code I thought this through very thoroughly. Now let me just catch the off by 1 correctly.
The one here is because you move from 2 to 1. So if it has more than 1, then actually you are not balancing. So that's the thing that you improve.
More than 1 definitely.
You improve it for the blue. You check that you improve from blue, because if you had 1 on number 2, actually you would move, for blue perspective, you move data and you remain in the same situation.
So would it be count less than 1 or less than equal to 1?
Yeah, that's exactly my off by 1 question now. I know I thought it through very carefully in the code, or somebody of you could just look.
It seems like less than 1, because if you had 1 on 2, if you had 1 on 2, on number 2, then by moving it, and you look only at the blue, then by moving from 4 to 2, you may improve globally, but you do nothing for 2. I'm not sure. I'm not sure. Sorry.
I'm just looking how I did it. Oh dear. By the way, the script initially started as a state printer where I just list and sum up the cluster state with displaying the PG offs. So I mean how much they are off from their expected PG count and so on. And then it grew and grew, and then I added moving sometime. That's ideal count. So we select the target candidate if the PG count is less than the ideal one, so no equal. Josh, you were right. Sorry for the confusion. Yes, so this does match. So we actually do move it, and then the new state is 2, 1, 1, 1, 2, 1.
Okay.
So that's from just looking at it intuitively, of course, better than having a 0. So now we just moved this new state a 80% here. So we have 140. And in this state we added and also have 140 here. Now let's select the next the fullest OSD, which is 0. There we also choose, because the selection of the candidate is so stupid, the blue one. And now we try to move the blue one to 1 first, but there the count check fails. Since we already have 1, locally it doesn't make sense to make the left +1, so this +1 here, no longer be a +1, but OSD1 is now the blue +1. So that's bad, and we don't do this because the count check fails. Now we try the next candidate here. Pool 1 now could not be moved off OSD0, so the blue pool is now removed from the candidates. So it only remains to move the red one, but the red one is not moved off OSD0 since the count of red is also checked. If it is code, no, I don't do it wrongly. Only if it's bigger than 1. But it is not. So OSD0 is not a good idea to move from. And now we have to empty the second to fullest OSD. Which is
4,
let's
this
see,
point.
160 exactly. So there the same thing will happen for the blue pool because blue pool does not have any, because blue pool will always remain the +1 since we have perfect local blue distribution already. So the next candidate will be 2 and 5. And now we skip the blue pool on 5 as well, because again the count stuff determines we have we only can remain the +1, and that doesn't make sense moving. And the red pool, the red stuff can be moved to 1. Like looking again from the least full device, we see that 1 has 0 PGs, hence it is less than 1. And so we do move the 3 over there. Are you following still?
Yep.
Yes. So now the new state is this.
Am I understanding correctly that this algorithm only takes into account a number of PGs, not how much space do they take?
So the space of each PG is accounted for when selecting movement candidates. So be on an OSD, you want to empty it, then I have a look at the PG sizes.
Okay,
And
but only on that step, yes?
yes, but when selecting an OSD that I want to empty, then I'm only interested in the overall fullness of that OSD. So the sum of all PGs on it.
Just it's not 200 because you already moved. It's 120 now become. It was 140 and you removed 120.
Ah, yeah, the one somehow. What? No, it's 2.
It's 140 because you already moved the blue one before.
Ah, oh yes, yes. Oh God, dear, yeah. That's true. And now we have on the second
100.
drive is 100.
No, not on this.
Here we moved it to 100, yeah.
Yeah.
So now we have 180, 100, 140, 100, 160, 120. So that's already okay-ish. Getting better. So we've filled up. So what we're still missing is filling up the 4. And we should ideally take 2 for that, just by humanly looking at it.
No, you want you. Yeah, well, it's strange. From local perspective, you're correct. You should fill up 4. From global perspective, you should fill up 1. And it seems like both are legal at this point.
Sure. It would move to.
I'm not sure. I agree. It should go to 4. But how can you decide now that it goes to 4 and not to 1?
I'll just write it here because it's so difficult looking up and down all the time.
No, so it's not 60. It's 140 on 3 on number 2. When
Number 2.
60, it's already
Why did I
140.
write 60 now? I'm an idiot.
It was 60, but it's now 140.
Yeah. You're also right. I'm getting tired. Long work day.
Don't worry, it happens.
It's 6 o'clock in the evening already and totally dark.
So
And
now, yes. So now you have yes. So you need to move red 1 from 2. That's we agreed on. You need to move red 1 from 2. From local perspective, if you want the pool to be spread correctly, you should move it to 4 because it doesn't have any reds.
yes.
If you look globally only, you need to move it to number 1 because it has only 100. So this is where I get confused how you decide what to do here.
So the order, the selection where I move to first considers the global size. So the candidate selection of now emptying 2 selects OSD 1 since it has only 100 and not OSD 4, which has 160.
Okay, so you are not so you miss something, and this is where I come to what Mark said. Now assume that one of them, let's assume the red one, it's smaller, but it has a lot of workload and especially a lot of read workloads. You kept from low workload perspective, not from capacity perspective. Number 4 doesn't have any read, so it doesn't really participate in the work at all. Yeah. So this is what I think that Mark was talking about, the conflict between balancing locally and balancing globally.
It's true, but now since we again do the +1 check and know the ideal amount is 1 and the being 2 is the second choice, it does not move from 2. So this is what we want to empty now, obviously. We do not move here because of the +1 check. So that is the count has to be less than 1.
Okay, because the 1 is not related to the number in 2, the 1 related to the optimal number.
Yes.
Oh.
So we don't do this. Instead, we try again with the next bigger candidate, which is 3, which is also 100. There the check fails same way. Then we have to try the 120 thing, which already has 2, which fails the +1 check even harder. So we are not moving here, we are not moving here, we are not moving here. And now the next OSD in the global size rank list is the 4. And there we do move it, because the overall balance does decrease, and it is not a +1 yet, it has 0. So what we do is move here.
Okay, so what I try to claim here is, oh, and you left, so on number 2, you're going to be left with, okay, I don't claim anything.
And now we do have a local optimum, because we only have 1s and 2s now. And globally, it's not ideal, but
these are the constraints that we have. Yeah, it's not ideal,
yes,
but it's under the constraint because of the size of the blue one.
yes.
And you actually can't improve a lot, because if you move red one, you don't have anywhere to move it.
I mean, what we can do is to relax this off by 1 constraint. So it is possible to move +1s around.
But then you are, yes, but then you are in.
So that the check, like Neha earlier said, is, so we
Yes,
add in a equals here. Then it's
then,
possible to shuffle
but
around.
then, yeah.
And
But
still,
then you
this
may
would
have
restrict
-2.
the local maximum, and the candidates are selected from the global maximum.
Yeah.
I mean, I can just add an option, allow moving +1s, which does exactly that.
It's not good in our example, but our example is very small because we don't have zeros or so. But it's, yes, but it's whether you favor global balancing versus pool balancing. It's because you can't do anything here as I see it. I think you can improve without breaking local balancing. You could improve globally by making one of the reds 0 or 3, or
Yes.
do some, and then the red is not balanced perfectly, but globally you are in better situation. So the global balancing is the fullness, which is functional requirement, which is very important. The local balancing is the performance issue, which is non-functional, but it's also very important. So yes, but it seems like it's either or.
Yeah.
At this point, by this.
Yeah, that's true. So Mark, your point is definitely valid that you have to do a trade-off here. But now we have really big chunks, right? I mean, we have only an 80 and a 20 chunk. I mean, we should have done that as megabytes or gigabytes, not percent. Yeah, but
the overall outcome, is that we have at least just emptied the fullest one, and just we arrived at a point where we have better performance distribution across the OSDs inside and out.
Yeah, but as we just figured out, if we do relax the constraint a bit, like allow moving the +1s around, then we can do even better. Because now the only movement candidates for red are OSD 0 here and OSD 4 here. And we can move that around to wherever we like. And the same thing for the red pool. So let's assume we do allow it, and we are currently in state. Like this. 1, 1, 1, 2. Like we're just continuing with the one we do have. like this. So now, what's the fullest device? It is either OSD 0 at the IDs.
Those with two blues. The two blues are the.
So which OSD would you empty first, 0 or 4? I mean, it would be random in the algorithm. So let's take 4, right? Because we just moved to it. So now biggest PG on that thing is the blue one, and the candidate for moving the blue one around would be the best candidate would be 3 or 1. And now you see, just by doing this, it doesn't make a difference, because if we move the blue PG to 3 or 1, then 4 will have 100 because we move 80 gigs, and this one will be 180, or this one will be 180. So you won't have 1 anything, because we only have this damn 180 chunk. This 80 gig chunk.
Yeah.
Or do you see a better distribution?
No, you can't move blue. The only thing that you can do again is move red from 180 to 100, and then you improve the global over the local. That's the only thing that you do.
And what would that concretely be?
You could move red from 0 to 1, for example. Then you improve globally, but then you lose locally.
Yes.
Or you have the equivalent from 4 to 3.
Yeah, indeed.
But anyway, then you empty up just 0, and depending on the performance needs, then you lose 1 of the OSDs for that.
Yes, this is sure a case of deciding what you prefer. It's functionally, from fullness perspective, you should prefer the global, but it hurts the performance in this specific case.
That's true. I mean, in there you really have to do the trade-off now. Do I want to keep the local optimum like that, or do I want to move them together somehow? And
I have a question now. Maybe I not forget something, but there are 2 different parts. One is that you basically asserted, and to some degree I agree, that the best distribution would be that puts PGs most evenly possible. So there was our 22111 scheme. And we analyzed this example, drawing OSDs that we somehow silently assumed that their size is equal. But I thought that your algorithm is relevant in a situation where you have one OSD being much larger than the rest. I mean, let's say 1 for simplicity. Am I missing something here? How it
so is? The OSD bigness and the fullness is always done relatively, and meaning that that's why I started writing percents here. So the order of OSDs where we move from or move to is given by the fullness percent. So a very empty OSD, which is very empty because it's so much bigger than the rest. I mean, let's say a 16 terabyte drive, would always be the first candidate to move to because it's relatively the emptiest one, so to say, right?
But it means that the very large, very empty OSD should be a target of multiple moves, in effect, aggregating multiple PGs, thus somehow breaking that +1 rule.
No, because we just don't use it as a candidate if we broke the +1 rule. So we
No, I
think,
think
oh yeah, that would be
the
empty
+1
and
rule.
publish.
The +1 rule. First of all, what you do is you take all the OSD and their sizes, and you calculate the number of PGs that should be associated with each of the OSDs, and this is a fraction, and the +1 relates to this number. So this number changes for the OSD size.
It seems like if you have a cluster that's heterogeneous with smaller drives and bigger drives, it seems like the strategy maybe that you'd want would be when the cluster is empty, you spread equally over the devices, and then as the cluster fills up, you start skewing more and more towards the bigger ones. Does that make sense?
It's a class for its future features, Mark. Actually, what you say is absolutely correct, but it's it's for advanced course. We're on first stage 1.
Yeah, exactly right.
Changing policy, because the main thing, it has a cost. So you say I start using a policy when the cluster is relatively empty, and when one device is over 60%, I start moving data. But then starting moving data has a cost. You need just think about the logistics. You need to how you notify the users that now you start doing all kinds of data movement and performance degrades and all this stuff. It's not that you're not correct, but it's not as simple just from a logistics perspective. But it is correct. When the fullest disk reaches some kind of threshold, it makes sense maybe to change policy.
Yeah, it's almost like you'd want to tell the user that you'll achieve full cluster performance up to this disk fullness, right? Like if we assume balanced distribution across disks, and then if you now want to change to the policy of I want to maximize space, availability, now that I've gotten to this amount of fullness, now you have to expect performance degradation because now we're going to start moving data around to try to maximize the amount of space, given that the cluster is now full and you have a heterogeneous distribution of disks.
Yes, you have two different, actually, when we talk about balancing in general, and it relates also to primary balancing, but it also relates to different sizes and everything. You have capacity balancing, which is maximizing the effective space of the cluster, and you have load balancing, which maximizes the performance. And they are in conflict when the devices are not on the same performance or the same size. When they're all identical, it works perfectly. But when devices are not the same size or the same technology, then it starts actually conflicting with each other.
Yeah.
Exactly.
But to come back to Adam's question, what Josh said, this +1 rule is applied to the relative fullness of the target OSD. And also we have to respect the crush rule still. So both of these things sometime limit after some iteration count limits trying to fill this huge OSD more and more. Adam?
Yeah, I understand that. Just I got with my own thoughts followed up
Okay,
in the future.
great,
So yeah.
awesome.
Yep.
Good.
Balancing is not that simple in such systems, but I think I really appreciate your work, Jonas. I think it's great.
Thanks.
Yes, absolutely. This was an excellent presentation and meeting together. It's fantastic.
My presentation wasn't that excellent. No. Usually they are better.
No, it was exactly what we needed to, and actually talk about it. So
Okay.
I thought it was fantastic.
Then I'm glad.
And actually, you gave. I think I got some ideas out of this discussion, especially, about the thing that we may need to give an option to run the balancer to optimize even the capacity balancer, just what we talked about, whether we want to optimize the capacity globally or we want to optimize capacity and performance by making sure each pool separately is balanced optimally.
Mm-hmm.
It's food for thought. I got a lot from this actually, so I think it was really, really good session. And you actually the plus one problem, I knew it exists, but the other problem that you solved, actually, I wasn't even aware that it exists. So it's great that you found it and fixed it.
Are you the maintainer of the MGR balancer currently?
No, but we're working on changing on adding primary balancing and doing some other work on it. So I'm going to touch it, but I'm not. I can't comment as maintainer.
Okay.
But we are going to actually start working on this these days. Actually,
Who is the balancer maintainer? Is he also here? No.
So Sage wrote it initially, and even before that, Loic, many years ago, had started in on a different implementation of it. But now I don't know if we actually have anyone officially maintaining it after Sage is done. Neha would probably know for sure. I do know that other people have worked on it since then.
Yeah, but I think that most people like you, Jonas, when they look at the code and then they go to find other ways to do this. One of the goals is to try to make the code more maintainable than it is now.
I mean, I would have done it, but the whole Ceph build process just takes so long. I didn't want to do this. That was basically the only reason. I did patches. You probably all know Kreut, right?
Sorry, what was that?
This company, Kreut?
Oh yeah.
Yeah, I did work with them a bit because they're also in Munich, and one of the founders is actually a friend of mine. And back there, we did Ceph patches and so on. But for this balancer thingy, I wanted it to be actually usable without patching the C++ side of the balancer validation. So that's why this is complete standalone module, and I don't reuse any of the, I think, pretty well written constraint checks. That's not just the strategy is so different, so that I didn't want to touch that. Yeah.
It seems to me like it's not a terrible idea to have the ability to choose different strategies.
Yeah. I mean, my thing uses the command line interfaces API, which is actually a bad thing and should be improved in another way, because in order to build up all the state needed for the correct balancing, I invoked like 10 Ceph commands with a JSON output. And the whole balancer then assumes that all these 10 commands are for the same state. But that really doesn't have to be the case. So if in the middle an OSD dies off, then the balancer will be very confused because the first 5 commands said something different than the last 5. So just getting the actual full cluster state out is currently impossible. And that's another thing worth optimizing, I guess.
Actually, with existing command line, the existing OSD map tool, it works on a dump file, dump of the crash state. Maybe if we could get information out of this, it could be a good idea for this tool as well, because then what you actually you make sure that the state is coherent, because you get the file with a state which is coherent and then work on this file. So I don't know how complex it is to extract information from
it's
this.
certainly not easy, but
it should be possible.
That's something. I mean, you should be able to start a transaction like in an actual database, read out stuff, and then close the transaction. But of course, all the tooling wasn't meant to be consistent like the whole store itself.
Yes, I think because there is a way to do a dump. I think a dump of this file, if I need to check it, I don't remember, but not to JSON, but then even if it's other text format, it's parsable.
I mean, what can be done to just mitigate it is to dump the OSD map ID, to dump the, basically the OSD map should be sufficient. Dump that, do the commands, dump it again, compare the ID. If it has changed in the meantime, say, oh, I won't do it, and crash.
Yeah, correct. Just compare the generation. Yeah.
But that's not a very elegant solution.
But it doesn't change that fast. So, it's not elegant, but it works.
At least it prevents the failure case.
Mm-hmm.
I'll write it down.
Actually, you could even do a retry immediately, and only if it fails like 2 or 3 times, then you could just say something happened. Yeah. I can't do it.
Okay. Yeah. Cool. Then I think we can finish up, right?
Yes. Thanks a lot.
Go ahead, Josh.
Yes, and Jonas, I probably, since we start working on this from the CPP side, and I may have questions or ask for your advice, so be ready to get some emails from me.
Sure. I mean, if the Ceph gets better that way, everyone profits.
A great job, and I was quite amazing that you could do everything totally from the outside. It's great, actually, really great. Thanks.
Yeah, thinking of it, it really took some work. I mean, I started it like 1.5 years ago, maybe. Just look in the commit log. And the initial prototype worked really quickly. But now all the development time added way more features, better selection, but the overall idea remained pretty much the same. But you can see that in the Git log. I don't even know what all the changes were. So if we want to integrate something like that, I guess it does need a big refactor, of course, because this thing is a prime example for a growing project without any intent letting it become so many lines.
One of
And
the neat things too, though, right, is that it shows that you can do something like this without the manager. And with the manager becoming more and more busy with doing many different things, maybe this is a little bit of a nice example that it's possible to do it without tying up the manager resources with this kind of thing.
yeah, I mean, what would be awesome if just by general architecture, Ceph does really not degrade into becoming a microservice hell, because I'd really hate that. And so from that point, I like having the manager doing the balancing, but it could be maybe done more distributedly. Like, this manager is now acting as the balancer, this manager is collecting as the statistics collector, so that basically within the manager, the tasks are again more clustered, even though only one of them is active.
Sure. I hope that we head in that direction. It'd be very nice if we didn't have the single manager trying to do so much.
Yeah. Yeah, also with the web interface, why does it have to be also on the on just one manager which does all the statistics collection?
Yes.
Yeah. But still, don't become a microservice hell. That's, I think, worse.
Sure.
We also have an OpenStack thingy running, and just last weekend we had really huge issues debugging it because the internal state corrupted wildly, and just figuring out where the messages are passed between all those microservices was really a hell, and Ceph's way easier to debug in comparison.
Sure.
Code's more complicated, of course, but yeah.
Even in a given Ceph manager, right? At least this proves that you can do it as a totally separate process or separate thread, right?
Yeah, for sure. But now if we do thread-wise activation, one manager has these threads active, the other one others, then it's probably already way better clustered. Cool.
So Josh and Jonas, the only thing I'd ask is make sure to CC Neha. And there are people in the core group that are working on some of this code too. So let's make sure that everybody that's working on it is in the loop. But all of this is excellent. I'm really glad to see you guys working on this. I think we'll make the code much better.
Cool.
Sure,
Because I
Mia
have
and
no
Laura.
idea. Yeah.
It's Mia and Laura working on this. Sure, we're.
I think there are a couple of people in core that have worked on this, so I don't remember who all has looked at it. But I just want to make sure everybody that has been is in the loop on it.
Sure.
Yeah, sure. Go ahead and write. I have no idea who you actually are. I mean, what parts you're working on and how hard you're employed and whatever. So I guess, yeah, it's fine.
Yeah, I'm kind of I don't know. I do a lot of performance stuff in various areas. Nominally, I guess I'm in the core group, but I do stuff all over the code base, I guess. So I don't know. Right now I'm kind of partially looking at Crimson, partially looking at the OSDs, partially looking at CephFS, less on RGW since Mark Kogan does a lot of the performance work there. But this stuff is I looked at this a couple of years ago, maybe 3 or 4 years ago, and then at the time Loic really jumped on it gung ho, and so I didn't have time, so I kind of just moved off of it since he was really interested in working on it, and then Sage kind of took it over. So that's from my perspective, that's kind of how the history of all of this. But now I'm just mostly observer and cheerleader for other people.
Okay. So what Ceph could really use, I think, I mean, Igor is, I think, doing a really awesome job now, is these bug hunter guys. People who are really just hunting down bugs and the nasty ones.
Yeah, I mean, Igor has been working on Blue Store pretty much since it was first written. When Sage moved New Store to become Blue Store, um, Igor had one of the biggest first kind of major modifications to the code base, and so he's very very intimately familiar with Blue Store's internals.
Oh, that's really great. But I mean, I'm not only developer, right, but also operator. And people always, or Ceph dudes are always amazed how you can be both. But what I found difficult, like, is when there's some critical thing, which is just some weird corner case, but still totally nasty for you, then basically you have to dig down yourself and do it yourself. Like this, I mean, it's fixed meanwhile, but I was really amazed that the rediscovery bug of remap data the bug is basically received no attention except from operators. Like when you move a PG from one OSD to another and restart the source, then this PG becomes degraded, even though the source is still there, and we could just happily copy it from there. I didn't encounter this in Octopus anymore, so I guess it was fixed by some other change or unknowingly. But this bug has existed for such a long time, and it was so hard to debug. And I fixed one corner case, which went upstream and improved things. But to conclude or to summarize, I'd really have the Ceph community have more people doing bug hunting of the nasty stuff.
Yeah, it's tough. I mean, I think at least internally, most of us on the core team are busy, like 110% of the time. So, things like this can be tough to get to. I'm guessing probably Neha and Josh are the ones that looked at that kind of code most recently, but whether or not that was an intentional fix, I have no
Josh,
idea.
are you also working on OSD and Blue Store and Rados itself? Yeah.
Sorry, I was talking about Josh Durgan, but Josh Solomon
Josh.
also.
Okay.
Yes, not
Yeah. No, just from a user perspective, I mean, we're in university, we have lots of money, but not so much manpower, and still we don't have as much money as some companies do, or at least the spending process is complicated. So basically what we then do is I have to do the debugging.
I used to work for an HPC center, so we were very much the same way.
Yeah. So that's why I'm saying if Ceph as a whole dedicated a bit more resources on fixing nasty bugs than on adding new features, I think it would benefit a lot.
Yeah.
Because it doesn't, at least in our community, in quotes, it doesn't have the best. How do you say in English? The best roof.
Reputation, or
Yeah, reputation, exactly. Yeah.
yeah.
For being a stable thingy, but for that we had the polls where people say, "Oh, please do more performance and more bugs and more features." And
Yeah.
Yeah.
In the very early days with Inktank, the features are the things that always get you funding, right? If you say you can do X, Y, and Z, that's how you get the in Silicon Valley the people that fund these things to give you money. And so there's always a conflict of trying to get money versus, fixing bugs, which those people don't pay you for.
Yeah.
Now, hopefully, it'll be more towards bug fixing and performance than features, but that's even now it's still a balancing act.
Maybe that's because Sage left. No more
Well,
features, only nasty fixing.
well, it's also big company, right? Versus a small company that doesn't have money.
So he's working at a small company now? Yeah.
No, I meant Ceph. When we started Ceph, it was a small company that had very little money, right? We
yeah,
had some money, but not a lot. And so, if someone said, well, you need to have these features to give you money, then, we make those features. But now at a bigger company, you can actually spend more time on fixing bugs than always adding new features. So that's part of the reason for Shift too.
Great. So let's see, my cluster doesn't crash and still has enough memory free. Just today it had another funny hang. That's another bug nobody's unfortunately looking at, but it regularly kills my cluster.
Is there a tracker?
Yes, it is. I can send you the link one second.
Okay, thanks a lot. I have to drop. It's almost 9 my local, almost 8 my local time.
Yeah.
Great.
Yeah,
Soon.
I the same. See you guys later.
Oh,
Thanks
Okay,
a lot.
see you later, guys.
Great work, Jonas. Great work. Thanks.
thank you.
And Jonas, I'll take a look at the tracker. I don't know if
Yeah, I can send you the link one second.
sure.
I mean, it's not critical, but basically, for whatever reason, way more PGs are allocated on one OSD than are actually placed there. And then it runs into the max PG limit and refuses to activate PGs instead of just not moving there. So then you manually have to increase the limit, and then restart the thing, and then it's happy again.
I was never particularly happy with the max PG restrictions that got put in place for a couple of reasons. It sounds like this is maybe it's exposing bad behavior, I guess, but then the limit's making it worse, right?
Yeah. I mean, what I do now is just increase the limit, and then it calms down. Oh, damn it. Where was that thing? There was this cool filter. My page. I found it. Can I send it? No.
Yeah. You could just put in the chat if you want, but or email is fine too. Let's take a look at this now.
But I also have to leave soon now.
Yeah, me too. Actually, I need lunch here. But okay. Yeah, I see. No one's.
I mean, it's not that bad. There's surely more pressing issues. But and I didn't pay for any support, so that's of course not actually a complaining.
Yeah, but this is the kind.
That's what I mean with people tracking down nasty bugs.
Yeah. The worst part about these kinds of bugs too is that they is many little paper cuts, right? That people feel like it's makes the makes stuff difficult because
Yes,
they hit these
definitely,
stupid
exactly.
problems.
I
And
mean,
they're
commercial projects surely also have similar problems. Internally, I mean, but with Ceph, my feeling is that these things surface more often. I mean, there's so many bug reports, which I'm so glad I've not ran into. But
yeah. But even like this one, the Mon Max PG per OSD, someone made this, added this warning or this restriction because people, I guess, were having too many PG per OSD. So they said, oh, we'll make this restriction and put this in place. Now they can't have too many PGs per OSD. It will prevent them from doing it. But
mm,
the unintended consequence is now the
yeah.
bug you hit.
But to make things worse, and I wrote it also here, is that there's absolutely no clue, no warning that you did hit the max PG ratio.
Yeah,
It
it's even
just doesn't
worse.
say that. The PG just remains in activating state, and you're like, where the fuck don't you activate?
Yeah, yeah, agreed. All right. I'm going to try to make a note of this so that we can bring it up in the core
Yeah,
stand-up.
maybe that's
I don't know who
at
will be
least add
the,
in the if you do hit the limit, then it should give an health error.
yeah.
Because if that is, then okay, the rest is still nasty, but you know where to look at least.
This may be a good one for one of our newer people to look at to work on because I don't think the fix will be too bad.
Yeah.
It's just someone should go in and take a look at it and figure out the
Yeah,
best way
sure. I
to.
mean, I didn't have a look
Yeah,
at it yet because the fix was easy, and I have other issues also.
yeah, exactly. But we have a couple of new employees that we've hired, and these are the kinds of ones that are good for them to look at because it gives them a project to work on that's not impossible.
Yeah. And I should, I hope I wrote there that 15 now, because it still says it's 14, right?
I think
I
so. Yeah,
proposed it.
yeah. I wouldn't be surprised if nothing's changed. It's not the kind of thing that, like you said, it's not super high priority, but it's still one of those things that affects users. So it's good to we should talk about it. All right, I'm gonna go. I should go eat lunch. And it sounds like you should go too. But I will at least try to bring this up in the meeting and maybe get
Yeah.
somebody to look at it.
But maybe you have another hint. What can I do to escalate some effectively? Use the mailing list, or how would you do that?
It's difficult because,
Yeah.
to be perfectly honest, probably bug reports from customers are going to be the first things to get hit, and then other things are high priority items too. Or if it's data corruption, certainly we had that a couple of weeks ago that Igor found. I don't know if you followed that at all.
I did, yeah.
Yeah, things like this, they can take a while. It doesn't mean that it's not important. It just means that
Yeah.
there's limited time.
This
So
is exactly the trade-off between new features and fixing bugs.
yeah,
Yeah.
and honestly, Ceph actually, I think as far as like projects go at Red Hat, we are still probably one of the more community focused projects. We tend to fend off the business people at the company saying, oh, we have to do community fixes first and then we bring those to downstream. And we're still very much that way compared to some other projects, but it's always a little bit of a balancing act, how much to fight and how much to say, okay, well, we'll focus on these, product issues or other things now.
Sure. But hey, in the
So
effect, so many people are using Ceph and are quite happy, so that's at least a plus.
yeah, and I do feel like the good thing now is that we are spending more time focusing on bug fixes and focusing on trying to make sure that the product is stable and that people are having a good experience with it. I can tell you, I don't know, were you using stuff back in like the Firefly days?
No, I started with Nautilus.
Anything back in that era from like Firefly, I mean, it was crazy. Everything's much better now than it was back then.
I never even touched file store, so everything was BlueStore from the start.
Oh, okay, yeah. In Blue Store, actually, it's not perfect, but it's much better in a lot of ways than File Store was. File Store had some really, really bad behavior when you grew the an OSD to be very large.
Hmm.
Do you know much about XFS? The way XFS works?
Not much, no. I did use it in one, or somebody did use it in a project where I had a glance over it, but not much.
So XFS has this concept of AGs, and when you create a file system with XFS, basically an AG is just a region of the disk where stuff tends to land. So you create a directory, and all the files in that directory will land in the same AG, so the same region of disk. There's performance optimization, right? You can hopefully end up having locality.
Yeah.
Well, what Ceph did in the file store days is it would populate a directory full of objects, files that represented those objects. And when a directory got too big, then it would split that directory into multiple subdirectories. And so you had a tree of subdirectories for all of the objects for a given PG.
And because it was local and still remains local, lots of data was moved around.
Yeah, exactly. So the problem is you create a subdirectory. That subdirectory might be in a different AG than the parent directory.
Yeah.
Now, when you split the parent directory, the files that were local in the parent directory are now still local to the parent directory, but are now placed in a subdirectory that no longer is in the same AG. New objects that get placed in that are not local with the objects that came from the parent. You do that many, many times, and all of a sudden now you have random distribution across AGs of files in one parent directory. You do any direct operation that requires listing or stats of those objects, and you're ping-ponging across the entire drive looking up information about them.
Oh dear.
Yes, it was very bad.
Okay, Mark. So see you somewhere soon.
Sounds good. Have a great day, Jonas.
Ciao, you too.
Bye.